Hello and welcome to this SRC Learning Essentials series video about quality of service and classification of traffic. If you are not familiar with our service routing certification program, you can learn more by visiting our website at networks.nokia.com/src. In this video, we will first describe the purpose of classifying traffic for quality of service. Then we will explain how the Nokia 7750 Service Router classifies traffic. We will then move on to discuss how classification of traffic is maintained through the network. Last, we will configure a QoS classification and show how it is implemented with different types of traffic in an ePipe service. Well, what is traffic classification? Traffic classification in QoS is required so that the Nokia 7750 Service Router can identify and group traffic based on customer service level agreements. Traffic is placed into forwarding classes. Each traffic class will receive individual treatment because each forwarding class can be allocated different resources on the router. This is especially important for QoS when congestion occurs in the network, so that higher levels of traffic will receive better treatment. For example, traffic is received on this ePipe SAP on a Nokia 7750 Service Router. One flow of traffic is voice and is considered high priority. The other flow is HTTP traffic that is considered low priority. The network Ingress SAP will classify the traffic based on the markings in the packets, then place those packets into the predefined forwarding classes. The voice traffic is placed into a higher priority forwarding class than the HTTP traffic, so the voice traffic is then ensured better QoS treatment across the network. Classification and marking of packets are implemented at different parts of the network to provide end-to-end quality of service. This is called per hop behavior, or PHB, because each router must identify traffic and provide QoS mechanisms along the path in the network. These points in the network are SAP Ingress, Network Egress, Network Ingress, and SAP Egress. Okay, let's discuss forwarding classes. The Nokia 7750 Service Router uses 8 forwarding classes to classify traffic. Traffic assigned to each forwarding class will receive individual treatment because each forwarding class is configured to use specific resources on the Nokia 7750 Service Router. Different traffic types can be mapped to the same forwarding class if required. When no SAP Ingress policy is manually configured, the default SAP policy is used, which classifies all traffic into the forwarding class of BE or best effort. Let's now look at all the different forwarding classes. Network control is intended for network control traffic. High priority 1 is intended for network control traffic, delay sensitive traffic, and jitter sensitive traffic. EF and H2 are also intended for delay jitter sensitive traffic. These 4 forwarding classes are all considered high priority traffic or premium level. Low priority 1 and assured forwarding are both intended for assured traffic. Low priority 2 and best effort are both considered best effort level traffic. In addition to classifying the customer's packets into the assigned forwarding classes, the SAP Ingress of the provider router marks the packets as either in profile or out of profile. Let's take a minute to discuss the packet profile concept. Out of profile packets have higher probability of being discarded in the network queues than in profile packet when congestion happens in the network. SAP Ingress supports 2 types of queues, the default priority mode queues and the profile mode queues. With priority mode queues, the profile is determined when the packet is removed from the queue. For example, if a packet leaves the queue at a rate above the committed information rate, it will be marked as out of profile. With profile mode queues, classification can specify a forwarding class and subclass before the packet enters the queue. The subclass indicates if the packet is classified as in or out of profile. If no profile is specified during the classification, the profile is determined when the packet is being removed from the queue, just like priority mode. We will not be discussing queuing in this video, but it is important to understand that classification can mark the drop probability of the packet at ingress. Queuing will be discussed in another QoS video. Okay, let's see how we create forwarding classes and subclasses in a SAP Ingress policy on the Nokia 7750 Service Router. The first step when creating a SAP Ingress policy is to create queues that the forwarding classes will guide traffic to. The next step is to create forwarding classes in the policy and associate the queues with the proper forwarding class. In addition to the 8 forwarding classes, the Nokia 7750 Service Router supports subclasses. which as discussed earlier are only used with the profile mode queues. Subclasses are used for more granular classification of traffic. There can be a maximum of 56 subclasses per SAP Ingress policy. For example, one forwarding class can have 56 subclasses, or each of the 8 forwarding classes can have 7 subclasses defined. In this SAP Ingress policy, two queues, Q2 and Q3, have been created. Q2 is a profile mode queue, and packets belonging to profile class AF, including subclass AF in and AF out, will be buffered into this queue. Subclass AF in will be for in-profile packets, and subclass AF out will be for out-of-profile packets. Q3 is a priority mode queue, and packets belonging to the forwarding class EF will be buffered into this queue. Q1 is the default queue for any SAP Ingress policy and is usually associated with best effort traffic. After we create the queues and assign them to the forwarding classes, now it's time to determine how each packet will be classified into a forwarding class at the SAP Ingress. There are two traffic classification methods for a SAP Ingress policy: multi-field and behavior aggregate. Multi-field is based on the packet headers and is able to read a number of header fields up to layer 4 of the OSI model. To enable this option, an IP criteria, IPv6 criteria, or MAC criteria policy needs to be created. Traffic is matched against a policy with multiple entries and will stop on the first entry match. Behavior aggregate does not use as complex of a policy as multi-field. It uses a single hit based on the special marking bits encapsulated in the packet. An arriving packet may contain more than one of these marking headers. For example, .1p and DSCP. There is a hierarchy defined to make sure that the classification rule selection is not ambiguous when there are multiple matches. Note, after configuring a policy with IP or IPv6 criteria in a multi-field, it is not possible to configure a MAC criteria in the same policy. Alright, let's talk about a different policy, the network policy. The network policy defines how packets are to be marked or classified when ingressing or egressing a network port. At the service provider's PE router, the customer packets that have been classified to different forwarding classes based on the SAP Ingress policy are now forwarded to the network egress port. Here the egress policy needs to mark packets appropriately before being sent out the network port. This is to ensure that downstream Nokia 7750 service router will classify the packets into the correct forwarding classes upon arrival. When a packet is received from the fabric and is about to be scheduled out the egress network port, the egress network policy is used by the port to mark packets with .1p bits if there's a VLAN header, DSC bits if traffic is only IP traffic, and EXP bits if MPLS encapsulation is used. In this example, the network policy by default marks all egressing H1 traffic with EXP6 in the MPLS header. As the packet travels through the network, the MPLS EXP marking does not change. When the packet arrives at the network ingress port, the network policy checks the packet and sees that the MPLS EXP bit is set to 6. It will then classify the traffic in forwarding class of H1 with packet as in profile. The SAP egress policy will then handle the traffic accordingly. As we will see in our use case, the network policy can be configured to modify how traffic is marked before being transmitted out the network port. Alright, let's look what we are going to do for our QoS classification case study. In this case study, we have an e-pipe service between PEA and PEB. There is a traffic generator that is going to send two streams. The first stream, which represents voice traffic, has the source IP address of 10.1.1.5 with the UDP port of 16384. This traffic will be classified using a multi-field method and sending packets to forwarding subclass of EF in and marking the packets as in profile. The forwarding class will then direct the packets to be buffered into an in profile queue of Q2. The second stream, which represents best effort traffic from source IP address of 10.1.2.5, is marked with the presence value of 3 and will be classified using a behavior aggregate method sending packets to forwarding class L2, and then the forwarding class will direct the packet to be buffered in a priority queue of Q3. On the same PE router, we will then create a new network policy and modify the egress mapping for the best effort forwarding class of L2 by changing the default MPLS EXP bits in the packets on egress. As the packets are sent to router B, we will leave the default network policy on PEB and look at the pre-configured SAP egress policy. We will then demonstrate how EF is still using the same forwarding class, and original L2 forwarding class is now mapped to an AF forwarding class on egress. Okay, let's log into our router PEA. We will now create a SAP Ingress policy. We will call it SAP Ingress 10. So configure QoS SAP Ingress 10 create. Okay, great. Now the first thing we want to create is our SAP Ingress policy is our queues. So let's create our profile mode queue, Q2. Great, I'm going to leave the default parameters. Let's create Q3, which is going to be a priority mode queue. Q3 create. Okay, let's create our forwarding class next. So we're going to create forwarding class EF, create. We will associate Q2 with our EF. Back. We will now create the subclass of EF in. Create. And now we will make sure that any packets associated with EF in are profile in. So in profile. Back. Now we will create our forwarding class of L2. Create. Associate that with Q3. Our priority mode queue. And then back. Okay, let's take a look at what we've created so far. We have our forwarding classes and our queues associated with our queues. So now we have EF in. So let's now create our behavior aggregate mapping. So anything with presence level 3 will go to forwarding class L2. So that's mapping presence 3, forwarding class 2. Now let's create our multi-field IP criteria. I'm going to call entry 10. Create. And now we will create match. We want to match on the protocol UDP for the voice. Okay. And within the UDP protocol, we want to match on the destination port equal to 16384. Great, back. And now what we want to do is set our action to anything that matches UDP 16384. We want it to go to forwarding class of EF in, so it'll get marked as in profile. And go to Q2. All right, let's go back. Let's take a look at what we've created in our SAP egress policy. So forwarding class EF in to profile in. We've got our forwarding class L2, and we have our IP criteria set to match that UDP protocol 16 destination port of 16384. All right, let's go to our SAP Ingress policy. Let's map the QoS Ingress policy to our SAP Ingress. So SAP 116 Ingress QoS 10 info. We can now see that it's applied. Let's go back. What we want to do here is we just want to clear our stats and make sure that traffic is getting mapped to our queues correctly. Clear service statistics SAP 116 all. Okay, so let's look at our show service ID 1 for our SAP 116 detail. Okay, let's go to the bottom here and let's look at our ingress queues. So we can see here we have Q2 as a profile mode, so it's offered as in profile and it's being forwarded as in profile. So, and we can see that our Q3, which is a priority queue, is coming in as low priority and being forwarded outside of the queue as out of profile. We are getting traffic and we see that everything is being mapped to the queues. Okay, let's look at our network policy. So the first thing we want to do with our network policy we can't make changes to the default network policy, so we have to create a new one. So what we'll do is copy the network one over to our new network of 10, and let's go into the egress. We want to look at when our traffic is egressing the policy, so the egress portion of the policy. So what we want to do is take a look at forwarding class of L2. We can see it's using MPLS EXP bit of 1. what we're going to do is change that, and anything for forwarding class that is out of profile, which our traffic is, we're going to map it to an EXP bit of 3. And we can see that that's been created. Okay, so the next thing we want to do is go back and apply that policy to the interface. So router interface to the P router, QoS 10, and we want to make sure that's applied. Okay, we can see now that it's applied. And our voice traffic will be getting mapped to the default of EXP5. So let's go to PEB and let's look at our QoS SAP Egress 10 that's been pre-configured. So pretty easy configuration. We have two queues, Q2 and Q3, and the forwarding class AF is being mapped to Q3, and our forwarding class EF is getting mapped to Q2. So go back. Let's take a look at our default network policy. Network 1. We'll go into info detail, and we'll look at our ingress. So we'll look at when traffic's coming in. So anything that comes in with the MPLS EXP bit of 3 will automatically get to the forwarding class of AF and will be set to profile in. Okay, so let's just make sure that this policy is applied. So we'll go to configure service epipe 1 info. We can say that the policy for our egress, the QoS 10 predefined SAP egress policy, is applied to our SAP egress. So let's go back, and the next thing we want to do is make sure how our traffic is being mapped. So we'll once again clear our statistics. SAP clear service statistics 116 all. Okay, let's take a quick look and make sure how our traffic's being mapped. So we want to again look at the show service ID1 SAP 116 detail. So let's again go down to the bottom. We want to look at our egress. So we have an egress 2, egress 3. So we can see traffic is coming forwarded in profile, and we can see traffic is being forwarded is in profile Q3. So we can see that our traffic that was a forwarding class L2 is now being mapped to AF into Q3. Thank you for watching this video. Content for this video was adapted from the Nokia Quality of Service course. You can access the complete course via any of the 3 learning formats shown on this page, as well as get remote private access to a Service Router lab to complete the course lab exercises. If you are interested in obtaining an SRC certification, this table identifies the recommended courses and required exams for each of the 5 available certifications in the program.